Hello and welcome to the Machine Learning Podcast, the podcast about going from idea to delivery with machine learning.
Your host is Tobias Macy, and today I'm interviewing Ori Silberberg about applications of AI for optimizing building construction at Buildots. So, Ori, can you start by introducing yourself?
Yes, of course. Thank you, Tobias. So my name is Ori. I'm the VP of Engineering at Buildots. This is a company where we use computer vision and AI to transform how construction projects are managed. And my role spans from shaping the technical roadmap all the way to ensuring our engineering teams have the clarity, the autonomy, and all the tools they need to solve the real-world construction problems. I was, still am, the first employee in the company, and it was something I did all the way through the past 7 years in Buildots was to help also shape the product itself. And not only shape like the way the engine works, but also what the engine does. So it's been a pleasure to work in Buildots.
And do you remember how you first got started working in ML and AI?
So I've always been drawn to solving complex problems. I love breaking them apart, finding the pattern, finding the structure, and then building them all up with a solution in mind. And one of the first things that you learn is that you can only do it one at a time if you don't use technology to do so. So my brain is great and all, but what I really wanted to do was to solve more problems and to do it whether I'm asleep or awake or talk to my beautiful baby girl. So what I did was I wanted to start using technology, and I created more brains that would work the problem. And the natural next step would be machine learning, because machine learning allows me to now not only solve more problems that I could solve myself, but by nurturing the environments of high quality data and designing effective educational paths, I can actually create brains or like a server that can now solve problems that even I couldn't solve myself. This was just like a very natural development of my desire to solve these problems. And I think this is what we do in Buildots as well, by the way, is we just solve problems. You can talk about which programming language we use, which type of which branch of AI we use, but at the end of the day, we have very complex problems to solve. We try and solve them. And AI is like a really great tool in your arsenal to solve them.
And so, digging into Buildots, I'm wondering if you can give a bit of an overview about what it is and some of the story behind it and the core problem that you're trying to solve.
Yeah, obviously. So the construction industry is huge, depending on how you measure it, but it's like one of the biggest industries in the world. And then the estimates are talking about like $13 trillion of an industry, sorry. And it is believed to have about $1 trillion $1 trillion of loss caused by delays in this industry. So this industry is not, it's very big, but it's not very effective and it's not reaching its full potential. So our founders, the founders of Buildots, sorry, they recognized that despite its size, construction is still lacking something. It's still lacking the real-time feedback loops that allows other industries like manufacturing to be as effective as possible and like to reach their full potential. And the idea was that we will take images explaining the reality of what happens on site. We'll take the plans, we will combine the two, and by creating the way to compare the plan versus the reality and do it often and time after time, we can really speed up the construction and the execution without adding any friction to the site crews. And what we've done so far is like we've analyzed something that is roughly 3 times the size of Manhattan, providing unprecedented visibility into what happens in construction sites. And we already help keeping projects on track and on budget.
As you mentioned, construction itself is a very large industry. There's a high degree of variability in terms of the scale and complexity of the projects involved. Everything from I just want to fix up the creaky front steps on my entryway to I need to build and plan an industrial complex or build a data center or build a skyscraper. And I'm wondering what axes of scale or what types of complexity you're looking to solve with Buildots, whether you're focused on residential, commercial, industrial, sort of the categories of construction that you're involved with.
So the first project we did was a large-scale residential project, and by then I was very naive. I was, at the beginning of a startup, and I really thought that we'll just, keep it residential, keep it like small and then progress as we grow. But what we really found was we don't have to do that. We built an engine that can just digest and analyze any construction site, and we need them to be complex in order for Buildots to actually give value. So we would never want to go to just fixing the front door of your house. We want to take the complex project. We want to take project where giving this extra edge of like optimizing them can really give value to our customers, but we don't limit ourselves to any type of project. So we so far did large scale residential, large scale commercial projects. We did hospitals, we did schools, we did anything you can even imagine, museums, train stations. We did airports, we did data centers, battery plants, even semiconductor fabs. We've done a few of those. If it is modeled, if it's modeled in 3D, we can do it.
In terms of the challenges that exist on the job sites for these different construction projects, I'm wondering what you see as some of the main sources of inefficiencies and delays, and some of the ways that you're trying to address those complexities in the process of actually planning and executing a building project.
At first, it seems like everything is it feels like, no project is anytime similar to another project that we've already did. And even for the construction experts that we work with, every project is special and every problem and inefficiency sounds special and unique at first glance. But then once you have the perspective that Buildots now has, which is we see so many projects, we see hundreds of projects of all types, you see that the inefficiencies just boil down to repetitive issues. They all have different causes, but they all boil down to the same ones. But I will go like one step back. Construction gets delayed for all sorts of reasons. Construction is so complex. It's a real world problem. But it's the realest problem you can see. And external factors like weather, like the scope and design changes, like model updates, the developer wanting to add the floors, to remove floors, to change anything, they can all happen. But our data shows that about 50% of the delays are truly caused by operational inefficiencies, by people not making the right decision in the right time and not doing it early enough. And it's impossible to do it without Buildots, and we'll go into that a bit later on. But what we've seen is that the complexity and the fragmentation of the work just cannot be managed using like manual processes as they are without Buildots. So delays, idle labor, miscommunication, incorrect assumptions, they're not an exception. They're not something that happens rarely. They happen all the time. And even with projects that use Buildots, they keep on happening. But with Buildots, we're able to nip them in the bud much, much quicker. But I will give a few anecdotes because the world is it's full of them. So I won't give any names. But in one of the projects, a GC team pushed the electricity trade to bring more people on site because according to the plan, they're supposed to. And each electricity worker will just install like 10 sockets every day or whatever. And another trade didn't complete building the walls it was supposed to according to the plan. So when the electricity trade would have brought more people, they would have nothing to do. They will not have any available sockets to install. So what happened there was the GC team kept pushing the wrong trade. They kept pushing them to do something that would just lead to idle workers, just lead to workers that we pay that take space that we do not progress in any other activities because they are there, they would have been idle. And one other thing that can happen, and again, I'm fixing the numbers so it's easier to understand, but they're not far away from truth, is say that an activity is supposed to take roughly 100 days. After 10 days, the superintendent, what he does without Buildots, what they do is they ask the trade informally, are they progressing according to plan? And the trade will tell them, yeah, probably. And based on that, they will, continue planning. They will continue bringing resources to site, both workers and materials. But what you have correct data and accurate data that comes frequently, that in reality, you were supposed to finish 10%. They can do it without Buildots. They plan to complete 10% of the work, but actually completed 5%. So now you need to ask yourself, do we have just a 5% gap? Or are we going at half the speed that we need to? And when you have frequent data captures, when you have the correct data, you know that they're going at half the speed. And then what you know, only after 10 days of starting the work, you know that they're going to be 100 days late. This changes the picture, and this changes the importance you put to this issue and how many focus and how many workers you want to bring on site. So with Buildots, this is just what happens. You find the issues early and you solve them.
For projects that aren't relying on Buildots, obviously there are numerous. Construction is an industry that is as old as civilization since we first started building shelter, and there have been many different ways to address some of the growing complexity of these construction projects, particularly when you're talking about industrial projects, things like skyscrapers that have a lot of interleaved requirements and very specific sequences in which the tasks have to be completed. When you're working with potential customers to onboard them, what are some of the typical ways that you are seeing in terms of manual and technical processes that the industry has typically relied on to be able to manage these sources of complexity and delay and waste?
So managing a construction site is something that used to happen until Buildots, and unfortunately for them, in all the pieces that are not using Buildots so far, it happens with a lot of manual processes. So there are a lot of people walking the floor with clipboards, filling out spreadsheets, marking it down on 2D maps. So the execution itself revolves around a lot of manual processes. By the way, their processes are amazing. This industry works with really low margins, and they have to be excellent to the best of their abilities. They have to be great. They have to plan well. So working on planning, you can think on construction as like building a waterfall project, right? You know the end result. You have to build it all the way through, and you have to do it efficiently, as efficiently as possible. So the industry really evolved their planning capabilities. So based on the lack of information they have, they built the best processes around. And so they built this idea. They have lean construction. They have like this sort of agile methodologies. They replan every week. They try and figure out what is the best way to move forward. But they're doing it all manually. So they use like sort of like the old agile ways. They have sticky notes pasted on whiteboards saying what they should do next. They have people walking around saying, I counted 100 sockets installed out of 120 that are supposed to be installed on the second floor. But it's all very manual, and it's all very based on gut feeling of the construction expert that walked the site. I would say it's not their fault. It's not their fault that they sometimes even just ignore even the manual tracking. Just doing it is most of the time isn't feasible. You cannot manually track hundreds of thousands of elements of small tasks and like figure out what are the final aggregated data results.
And the information age, the internet, these have had massive impacts on many areas of industry and ways that we work, and even introducing new categories of products. But with construction being firmly cemented in the real world, it seems as though it's very resistant to digitization. Obviously, there are project planning tools that you can bring in. There are computer assisted drafting that has accelerated the accuracy of being able to build blueprints and transmit those building plans. But I'm wondering, what are some of the ways that the construction industry is resistant to digital transformation because of its very physical nature?
First of all, I'll go back to my prototype answer. Construction is fundamentally a prototype industry. No two projects are exactly the same or behave exactly the same, and each site has its own operational environment that is being actively built throughout the project itself. Often without reliable infrastructure, they don't have electricity. To many floors, they don't have internet. Everything is packed with heavy equipment. There are logistic challenges. There are different trades. All of them come together for a single project and then disband to move on to the next ones. And many of the workers are not tech savvy. And the construction workers themselves, you can ask them all you want, like to fill out forms or to use tech, but they may not know how. And everything here is just like a construction project. It sort of builds its own ecosystem and then disbands afterwards and starts again somewhere else. And in this environment, it's very hard to streamline anything new. It's very difficult to change anything. Whatever is like the norm in the industry sort of keeps being the norm because you keep getting new people. You can't change their behaviors or teach them new technologies very easily. But I would say that I think that a lot of things have changed in the construction industry. Planning moved through amazing changes and revolutions in the past years. Uh, the industry moved from working with 2D drawings to having BIM protocols like 3D modeling that is super precise and exact. And we use that. And the fact that the environment itself has a lot of new tools, a lot of planning tools, a lot of management tools, really help Buildots reach a place where we can actually build something that uses all of this information that is now structured and in the cloud.
So, digging into some of the technical applications that you're building at Buildots, I'm wondering if you can talk through some of the ways that you're able to leverage AI and machine learning to this very complex and messy real world problem.
Okay, so Buildots AI is not like sprinkled on top. This is the core of what we do. Buildots could not have been created 10 years ago. AI had to reach a level of maturity that it had in recent years that made it possible to finally tackle this real world problem that has such vast complexity that is like fixing or optimizing construction sites at scale. So what we do is we take computer vision to extract data from noisy, imperfect 360 degrees site visuals. We take 3D models of millions of elements and classify them and like extract and we have to separate between cold water pipes to hot water pipes, and all we have are these like unstructured metadata fields that are inconsistent all over the world. Like no architects in the US or in the UK don't use the same attributes on these elements. So we have to classify 3D models. We have to detect precise locations and to unblurry and to white balance the images coming from these noisy construction sites, where everything is always a bit darker and a bit blurrier than we would hope and compare the two. And what we do is we actually build like this engine that creates layer on top of another layer that always enriches the data to get to the next step where we can run more algorithms. Some of them computer vision, some of them CNNs, some of them are just like data models to get more and more highly enriched insights. So we start from like images and we get all the way to like predicting what is going to be the delay of painting the walls on level 5. So getting from here to there means we have to use an arsenal of a lot of algorithms. No one algorithm is going to be enough.
And the other aspect of bringing AI to bear on this problem is that you need some sort of digitization to act as inputs to the AI to be able to operate effectively. So, obviously, in the very early stages of the project, a lot of the inputs are already going to be digitized. The 3D models, the CAD designs, the bills of lading, the inventory, etc. But as you actually start moving from that planning phase to manifesting things in the real world, that's where things get messy and complicated. And so then you have to be able to transform those real world on the job realities into more inputs for Buildots to be able to operate on. You mentioned computer vision, but I'm wondering if you can talk through the elements of data collection, particularly ways that you're able to automate it so that you're not adding yet another concern for the people who are already very busy trying to get the job done.
You mentioned the 3D models and all the already digitized inputs. And I want to say that even there are a lot of complexities because, as I said, 3D models are not all created according to some very strict protocol and are built in the same way. And what we find is that construction sites have such tight deadlines that even when the site actually begins construction, not everything is already modeled, and they do it like as they progress as they go, and they update their models and they start with design model and then fix everything that they need fixing throughout the life cycle of a project. So even there you have a lot of complexities and missing parts and that we have to somehow solve to give a reasonable product. But when coming to the visual and the reality capturing part of it, so the input that we started with was 360-degree cameras. And the reason for that is that we wanted to disrupt the site team as little as possible. And with a 360-degree camera, they can just walk into a room and walk out. They don't need to do anything else. So today it takes 1 or 2 minutes to just walk a relatively large floor doing a dedicated capture. But from there, we evolved. We evolved to not rely solely on the 360-degree cameras because when working outside, when working on vast spaces, they're just not good enough. We work on projects that span many square kilometers, and people who would walk there would just, have to will have to open their tent and spend the night. So what we do there is we use drones. And I think one of the most amazing things that I've seen our infrastructure with one of the most amazing things that I've seen our engine adapt to is actually changing the input from these 360 degrees cameras into drone footage with just like a few weeks of work, nothing more, because we just built the right engine, we built the right infrastructure. And by the way, this is something that we constantly work on like making sure that we're not tied to any sort of input, to any sort of specific construction site. We want to be able to adapt quickly to the changing ways of construction. And so another thing that we did about a year ago, we introduced LiDAR scans into Buildots, which also felt like is a great achievement for our infrastructure and design, that just adding another input is just as easy as plug and play.
So for construction crews that are using Buildots, I'm wondering if you can talk through some of the ways that it shifts the overall approach to the project and the ways that it integrates into their work day to day and from start to finish.
Until recently, we focused on helping the GC site teams and owners deliver projects more efficiently. Delays, more on budget, etc. It was by spotting activities at risk of delay, it was by resolving unfinished work, simplifying reporting, or just simply improving the collaboration on site. But we've now significantly widened the scope. We realize that by having this sort of data, we can change many more processes in the lifecycle of a GC company, not only the GC site. So now in Buildots is now not being used only by the site team, but also by the senior executives to manage the entire portfolio. To now not only point you as to the biggest risk in the project, but which projects have the biggest risks and which projects need more focus from the senior executives teams as well. And now Buildots can be used much earlier in the project lifecycle, and even before, by the way, the first bulldozer reaches the site. When you know how construction works, when you have the benchmarks of how things can progress, even looking at a schedule and 3D drawing without even seeing the actual footage from the site yet, we can already tell you if things just don't have a good chance of working as planned. If what you're planning is just unrealistic, and to revisit your plans from the beginning. So I would say we're working with an industry that created and follows a lot of great processes, and the processes are trying to handle the lack of transparency and predictability. And what you get when you introduce into these already existing processes correct data, when you input the right information, you do it at the right time, and you do it in the right format, all of the existing processes just start making much more sense, and they output great planning and resource allocations. I want to give another anecdote that is relevant to this sort of how do current processes simply change with Buildots. There was this one hospital project in the UK where the superintendent noticed using Buildots that some delays start to accumulate for the electricity trade. And they asked the trade, how can it be? Since they knew that there were many electricity workers on site. And soon they realized, by talking to the trade and looking at the data in Buildots, that the electricians waited for another trade to finish, and there they waited for them to finish their raised access floor installation. And they waited because they knew that there is this dependency, that they couldn't continue working until they finished their raised access floor installation. But it wasn't really needed. It was something they decided they wanted to do back when they started planning the site. But in reality, they just could eliminate this decision. They could reverse this dependency, and it sped up the progress of the project immediately with a blink of an eye. And this thing could only happen if getting data was so easy. And by having this discussion with the electricity trade, they could just pull whichever data point they wanted.
And so, digging now into the engineering work that you've done to create Buildots, I'm wondering if you can talk through the technical architecture and design of the system that's powering this experience.
Okay, so I'll do my best to explain that without needing like a football field-sized whiteboard behind me. Okay, so I look at what our technology is doing as like generating data, generating more data that is getting more enriched and more complex the more you continue and like get away from the source, which are the 3D models and the videos. So we create a detailed digital twin, a digital representation of the construction site in our database. Doing that is like taking a real world problem, something that people sit in university learning like all the complexities, all the dependencies, everything that explains what a construction site is, and modeling it in a database is complex. It's complex because you have to now enforce relationships. You have to enforce what it means for an activity to be. Does it always belong to a single trade? Is a level always in a single building? You have to model everything and to create the restrictions. And you want to limit the flexibilities if you model as much as possible so you have easier time creating the next features. And when you build the right model, and we believe that today we have the right model, or at least a right model, this allows our construction experts to now onboard any site, any construction site, a hospital, a school, as I said before, a residential, commercial, any site into Buildots quickly and accurately. And what we do afterwards is whenever new videos are uploaded, when a construction site somewhere in the world uploads videos into Buildots, our Kubernetes clusters spin up thousands of cloud servers running dozens of computer vision and deep learning algorithms in parallel. And this is where the raw imagery gets turned into structured, actionable data. And finally, once we have all that and we have the plans of what is supposed to happen, we have the reality of what is happening as captured in the images. What we have then is finally we can now take all these new data points. Right? Finally, every time a new data point is added to the platform, from a processed video, from an updated model, or a client schedule change, our engine can now reprocess everything. They can reprocess the full context of what is happening on site, update the progress tracking, to update the deviation analysis, to update the risk forecasting, everything. And I think that one of the most interesting things that happen in Buildots is that the reality changes often. So many times what we'll have is like a client telling us, finally, I have this 3D model of the MEP ready for you to analyze. Can you please analyze back like the past 4 months and imagine as if this model had always been there? And we had to build an engine, a platform that supports that supports any change, supports any update by the user, and to fix the history, to fix the present, so we can fix the future. We had to build that, something very robust.
Working with construction projects, dealing with real world requirements, dealing with the creation of structures that need to be safety, need to conform to various regulations. They need to be able to withstand whatever environmental factors are present on site. That brings a lot of risk along with it. And so, given the fact that you are providing inputs to the ongoing work to actually create these structures, that I'm sure infers a certain amount of risk to you as well. So, given the safety critical nature, the regulatory nature of the construction industry, I'm wondering how that influences the ways that you think about which types of AI models to use, the selection of those models, and how they actually get applied, where to incorporate human input and feedback, and all those various considerations.
We prioritize reliability, which I'm sure in many industries you have to do that as well. But we also prioritize explainability. So our models are not designed to replace anyone. They're not designed to replace the decision-making process. They're designed to assist the decision makers. And to do that, we provide clear, auditable data trails and not black box outputs. So every data point you see on the Buildots platform, like as a user, any data point you see, you can track back to why this number is what it is. And if you see that Buildots tells you that you're going to be late unless you change anything for this reason, you can now dive into all the elements that we've seen, and you can see the imagery of like this socket was installed, this socket was not installed, this one was installed 2 weeks delayed. You can see all of that, and always it helps us by building trust. It helps our clients by having the proof to show the trade, like the subcontractors and everyone else they want to actually explain why they're making the decision that they're making, and it helps them by verifying that what we tell them is indeed true.
Generative AI and large language models have brought in a new style of user interface to numerous different products. I'm wondering how you're thinking about the application of AI to simplifying the ease of use, the onboarding, the styles of interaction that your customers are having with Buildots, so that they don't have to necessarily spend a lot of time figuring out what are all the different knobs and dials and nooks and crannies of the product. I just want to know, what do I need to know and how do I move forward?
Okay, so I'll start by saying that we are still learning. I think that Gen AI is like, taking the world in a storm, and we still experiment with how Gen AI can help us simply be faster and better at what we do. Just building the right platform, but also how to use it like more exposed to the clients to help them get more from Buildots. So 2 things that I'll say that we already have facing the customers themselves. I'll take 3. So the first would be we introduced a few months ago. We introduced Chat Agent, an LLM-based chat agent that exposes the Buildots data, or actually the user's data, as generated by Buildots to the customers. So now customers can, instead of understanding how to use, our pretty great UX, but instead of using that, they have this specific question in mind. They're now in a trade meeting. They just want to know something. They can now go to this chat agent, just ask them whatever they want to ask. And what happens behind the scenes is that we understand what are the entities they're referring to, and the LLM generates an SQL query that queries our database and outputs the results and delivers it to the client. And this allows our customers who are still not fully onboarded on the Buildots platform, or just don't have the time to now, traverse the various screens, to get the input they need as quickly as possible. So this is like Gen AI to the customers themselves. Another thing that we're doing is we're now creating amazing onboarding videos using Gen AI. So we have Buildots avatars that are now the face of Buildots and like explaining every new feature. And now onboarding clients can be much more streamlined using very fine-tuned videos. So this is the second. And I would say the third is Buildots is building, at the end of the day, a B2B software. And we're building something that helps our customers improve and optimize the work by so much that since Buildots is a B2B software company, we do not shy away from building complex software as long as it produces enough value to the customers. We need to earn their attention.
The AI landscape is obviously under constant evolution. It's moving very rapidly, particularly in the generative space. And I'm wondering how you're thinking about the future trajectory of Buildots and the capabilities that you can add in light of those new underlying model capabilities, new architectures, new ways of structuring the different models, particularly thinking towards agentic use cases, and just some of the ways that you're thinking about the potential for bringing even more capability to construction crews that are relying on Buildots for their project management to be able to get more useful insights, maybe even help with the generation of blueprints, construction plans, etc.
Yes, so I think that Gen AI is very useful in helping people interact with computers, but you need to have like reliable data behind the computer in order to streamline and actually get value. If you don't want to just help a user refine their own thoughts, I think that Gen AI may give Buildots like another very tall step to stand on. We now work on helping customers generate plans, generate their program, and we Buildots now know what programs are possible, what programs are good and will lead to the maximum efficiency, and the ability to now have this feedback cycle of a customer like just telling the computer what he wants, what they want, can make this process much better. It can now take the data that Buildots has and actually take all the needs and the requirements that a user has that we will never be able to encapsulate. Only this type of Gen AI can help us do it very efficiently. And I think this is like an amazing thing that we could do in the future. But as I said before, I think that we're still learning. One of the things that we are doing inside the company is that we're taking each department, sales, marketing, engineering, algorithm, research, and we make sure that they are all trying to improve as much as possible by using Gen AI. So you have all these Slack channels where everyone who notices anything valuable that they've used AI for, and they post it there, so everyone can now try it. And we use Gen AI based IDEs, and we use Gen AI when we write emails and when we draft messages, because we want to hone our skills and to constantly understand what Gen AI can do for us. And from there, we believe we'll get more and more ideas on what Gen AI can do for our customers as well.
Another element of the construction industry is obviously all of the paperwork involved in getting building permits, verifying that you're in compliance with the local regulations, but also the systems within which the project exists. So things like the electrical grid, the effects on the local environment, whether you're disrupting any natural water sources, et cetera, et cetera. And I'm wondering how you're thinking about the potential for Buildots to be able to assist with some of that tedious work of the paperwork, as well as some of the planning around the broader system in which the project exists.
First of all, I'm not sure that I ever thought of that. So I'll try my best. I think that in general, in the construction industry, what we are seeing today is that more and more startup companies and even old tech are finding their way around this industry. We add more and more data sources in more and more parts of the construction process from before a project site even exists, from before the bidding on the future construction site even ends. More and more data is getting digitized. And I think what we'll see is that the integration of more sources coming together is actually going to bring us the next leaps. And I think what Buildots brings is the data of what truly happens in construction sites. I'm not sure how it will benefit the domain that you just said, that you just mentioned, but I'm pretty certain that only by integrating all the data points you can get to the true optimization of this industry.
Yeah, I can also imagine some potential use cases on things like urban planning where you say, okay, I know that this construction site is happening over here, this other construction site is happening over here. How is that going to impact traffic patterns, electrical loads, loads on the water supply, et cetera, et cetera?
Interesting. Okay, so one of the things that we are creating is the ability to classify and analyze the 3D models in a way that actually correlates to the design of the project, to the way the project is going to be managed and actually be built. And from there, we already see many insights that we can bring to the table, like possible clash detections, like where misplacing a pipe by even just a little bit is going to create havoc because you won't be able to install another element. And I think when we'll be able to take larger models, not only describing the construction site themselves, we may be able to get to what you're saying and like getting it all together.
And in your work of creating the technology behind Buildots, working with the customers, working with the elements of the industry, I'm wondering what are some of the most interesting or innovative or unexpected ways that you've seen your product used?
One of the most inspiring moments, at least for me, came from a project manager in one of our early UK projects. It was someone we now consider a true super user and a true champion to Buildots. And after working with Buildots once, he refused to ever join another project that doesn't have it. He had an incredible ability to turn raw data into insights. So we have this feature that just exposes a lot of just like a gigantic data table on the project. You can see anything happening for each area, for each activity, like a very, very massive table. It's there for, like just diving into the tiny bit of details. And what he did, he was somehow able to identify trends, to identify the risks, the one that even we didn't envision, we didn't figure out could be extracted from the data yet. And his creative use of the system actually inspired us to develop new features that made those kinds of insights now accessible to all users, with his permission, of course. And this was a powerful reminder that the best innovations often come from the people closest to the problem and not from people sitting in their cushioned seats in the startup company far away from them.
And in your work of building this technology, learning more about this particular industry and the challenges that it presents, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Okay, so I think that one of the biggest lessons that I've learned, it's very counterintuitive to someone coming from the tech industry, is that clarity almost always beats complexity. It's better to be simpler than being more precise and more accurate. Even the most sophisticated algorithms, they just don't matter if they don't produce simple, actionable insights. And customers will happily trust and act on a data point they can understand and validate, even if it is less accurate, but they will hesitate if it feels like a black box. So this is one. Another interesting engineering challenge we had is managing our assumptions on how construction sites behave. So as I said before, we are modeling a construction site. When you do that, you need to make assumptions on how things are built and what every construction site in the world has to abide by. So let's take buildings, for example, very simple example. Let's take building. When you talk about a level, you could assume that a level will always reside in a building. But then you get to the next construction site where there are two buildings connected by this like bridge floor. And now you scratch your head and wonder, where is it? Do I need to now remove my assumption that a level always resides in a building? And if so, what is going to happen there? It's like a many-to-many relationship, and how do I change my entire product to support that? Do I just ignore it, just split this floor half to building A, half to building B, and just move on with my life and like hope it will never come back again to haunt me? So modeling things well is very difficult. Modeling a real world problem like construction is almost impossible, but you don't need to do the best job. You just have to do a good enough job. You have to model the world in a way that is simple enough to actually use and build a platform on, but complex enough to support the value that you want to provide to the customer.
And as you continue to build and iterate on the product, you continue to explore and stay apprised with the AI industry that you're operating within. What are some of the things you have planned for the near to medium term of either the Buildots product or the potential applications of AI to this problem domain?
Yeah. So we aim to make construction companies more performance driven. We want to help them achieve operational excellence, and we want to help them deliver projects on time and on budget and everything else that our marketing department can articulate so well. And to do so, we need to give the construction team superpowers. We need to give them the ability to see risks before they materialize, and we need to to help them to mitigate delays before they escalate. And we have to be able to predict better with less data. We have to now take not only the data that is created in the current construction site, but to learn from all the construction sites that we already did, so we can use like the first one, two, three data points in the construction project to already generate the insight that will help this team optimize their own current building. And to do so, we have to be much more accurate. We have to always push forward with like modeling the world better to find all the dependencies and to find all the connections that we now miss. And this will result in creating much more complex algorithms that require a lot more data we can actually build. Something else that we have to do is to expand into more phases of the project lifecycle, into superstructure and the facade and everything else that revolves around like the building itself that will give like the full picture.
Are there any other aspects of the work that you're doing at Buildots, the challenges of providing automation and insights to the construction industry or the overall potential for applications of AI to construction and real world problems that we didn't discuss yet that you'd like to cover before we close out the show?
Okay, so I want to add something that is like the way we tackle problems with Buildots and the way we see AI. So to us, AI is one of the most important tools that we have, but what we are trying to actually do is to solve problems. And I'm coming back to the beginning of the show, like what drove me into machine learning. So at Buildots, we're trying to solve a problem. Our problem is how to optimize the construction site, how to deliver these insights. And the way we do that is by taking a problem and always create engineering and algorithms and an AI that helps us split this problem into smaller problems and to keep doing so until the problems are just small enough for AI to completely automate them. And what you find in a real world problem is that it's never easy. It never is like a very simple problem, a predefined problem that you just know in the beginning that you just need more data to solve. What you truly need is to uncover the true problems that lie underneath the big one, the what I need to solve in order to reach this final solution. It's a big problem. And I think this is what we've done for 7 years in Buildots, is to continue take problems apart, to continue splitting them more and more until they are so easy to explain to another human being and so easy to explain to a computer and to a CNN, to an algorithm on how to solve. And only when you reach this granularity of problems, you can actually move on to the next challenge. And I think this is the way we see AI. AI helps us split the problem, and AI helps us solve the smaller problems, but we still need like the people behind it. We still need the creative people to see the patterns, to use them all, to see the patterns now, and to understand how to truly solve the complex problems.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling technology or human training that's available for AI systems today.
I think that at least what I've learned in Buildots is that it's all about the context. You need to give the algorithm you're building, the LLM or whatever proprietary algorithm you're building, you need to give it the right context. You need to understand what data you actually need to feed it in order for it to get to the right answer. And to understand what is the true context today requires creativity. It requires legwork of understanding the problem. It requires us at Buildots to go to site teams and to go to construction sites and understand what it is to build and what it is to manage, what it is to explain a construction site. And only once we do that, we're able to now, feed it back to our algorithms, feed it back to our engine and our software architecture, so we can truly solve the problem. So AI is a great tool. It's a mandatory tool if you want to solve complex problems, but unless you give it the right framing, the right context, the right data, not just tons of data, it will just not work. So to me, I think being able to do that is one of the things that stops like the experienced and talented individuals from like solving the next problem.
All right. Well, thank you very much for taking the time today to join me and share the work that you and your team are doing at Buildots and just the overall challenges of trying to add digitization and operational efficiency to such a inherently physical real world problem. It's a very interesting project, interesting problem area that you're attacking. And so I appreciate you taking the time today to share your thoughts and experiences on that. And I hope you enjoy the rest of your day.
Thank you, the best. You too.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcasts.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.